Hello, everyone, and welcome to another episode of GDDV 100 Game Theory 1. My name is Kasanas. All right, guys, we're not doing so bad here. We're all in isolation. We're all watching these videos right now. If you're watching us in the future, I hope the future's bright. I hope the future's sunny. I hope COVID is gone and we're all outside playing in the park or something awesome like that. But for now, we are inside watching these videos, and I really hope they're helping you out. I think my students are doing really well. All right, guys, so we're not doing bad as far as our weekly progression is concerned. We're moving along pretty well. We are moving into week 7. So far, we have done course intro, what is game, design thinking, flow states, immersion, narrative, character quest, and today we are doing game loops. All right, and particularly we're going to take a look at two different styles of game loops. There's two different styles of game loops. Something that the industry calls game loops, I've divided into two different groups, two different categories. Those categories are game loops and play loops. Now, not everyone says play loops, but I do. So I'll be referring to them as play loops sometimes throughout this particular video. All right, everyone, let's get started. So let's explore game loops by starting off with what exactly is a game loop. And there's a couple of different definitions of what game loops are, and we're going to look at a couple of different definitions of what game loops are within here. A game loop is a collection of actions and responses that are repeatedly encountered throughout a game by the player. A game can consist of various game loops that vary in frequency and timing, and that's pretty important. We're going to look at two different definitions. They're not really different definitions, but we're going to look at really two different versions, I guess, of what a game loop is. In the first, we're going to take a look at the idea put forward by Daniel Cook about a game loop being interactions between the player and the game itself, and being able to understand a game through this loop that occurs, through this feedback loop that kind of occurs. Not like the feedback loops we talked about previously when we talked about the idea of positive and negative feedback loops, but a loop that occurs in updating one's mental model of how something works. That's Cook's definition of it, and we're gonna take a look at some of Cook's diagrams in just a moment. We also are gonna talk about what I like to call play loops, and play loops refers more to dynamics of play, where things occur within a game, dynamics occur within a game, basically dynamics occur within a game, and it forms this play, it forms our play. And we'll get to that in just a moment here. But let's start off by taking a look at Cook's concept of game loops. And really what it is an interaction between the player and the system in which they're interacting with. To break it down in really, really simple terms, the player does something, the system then gives the player feedback, and that feedback is then used to update the player's knowledge of the game. That's in really, really simple terms the way Cook looks at the idea of a game loop. And this is the diagram that's often put forward. In this particular case, what we've got here is we've got a mental model. And we're going to look at this really quickly. We've got a mental model, which means that we have an idea of how something is going to work. And when we perform an action that we think is going to do something, what happens is that action then feeds into the system. The rules evaluate that action and provide feedback for us. And from that feedback, we are able to update the way we think that this particular item is going to work, right? For example, if you are playing an infinite runner and or if you're doing anything else, if you're playing a game and you push a button and a door opens, well, then we know that every time we push that button, the door will open. That's in really, really simple terms. Looking a little more in depth at it, the mental model that we have concerning anything really, but we're going to look at it in terms of games. The mental model we have in terms of games is formed by a number of different things. If there are some type of genre constants, we expect that a game we are playing within that genre to operate in a very similar manner. There can be things like past experience. We've played other versions of these games. We've played, 1, 2, and 3 of this particular game, and we know that these particular actions are going to do a particular thing. So we have this mental model that's formed by our past experience. We can also form a mental model simply through affordance, and affordance basically means that we are able to look at something, and based on the configuration or based on the input we're getting from looking at this particular object, from the way the object is designed, we assume it works in a particular way. That's what affordance is. So there's a bunch of different things that allow us to create our mental model of how something is supposed to operate. Now, based On that mental model, the player in a game is going to devise a particular action they're going to perform. And once they perform that action goes into the rules or into the system. And once the system has evaluated the action, it's going to provide feedback to the player. And based on the feedback that the player receives, they are then going to be able to update their mental model. So it's if we take a look at an example of something like a side-scrolling infinite runner, if you've played that before, typically it's a one-button game, and we know that one button is typically the spacebar. If we press the spacebar, we think what's going to happen is our player is going to jump. So in this particular model, in this particular loop, that loop where we press a button and something happens, if we press the button and our player jumps, well, the button press, the action itself goes into the rules. The rules then evaluate it. Whatever code is associated with the jump evaluates the input from the player, and then we will see something happen on the screen. If our player jumps, then that confirms our existing mental model, and we understand this is what's going to happen every time I press the spacebar. We are teaching our players to do something, right? This is what we're really doing. We are teaching our players to do something through feedback. Now, if, however, our player doesn't jump, then our mental model will get updated. There might be a moment of confusion, it didn't work, and then we're going to try and figure out exactly what did work. But either way, if we are given feedback of some kind, we will update our mental model. We'll either update our mental model to a new existing concept, or it will confirm our existing mental model, and we will continue to operate as such. So, there's a couple of things that can happen whenever we are talking about this type of feedback loop, this type of game loop. And this goes into the idea of play testing your particular game loops. It's extremely important to understand that entire interaction. Things can break down for your player and for your game if you don't understand the particular interaction, or your player doesn't understand that particular interaction that's going to occur. So there's a few things we need to understand in playtesting our game loops, and you absolutely should be playtesting your game loops. In fact, you'll be playtesting them automatically, and your players will give you feedback every time you playtest your game. So the first thing we have to understand is that our players have no understanding of the rules within our game. They didn't write the game. You understand the systems and the rule sets that you've got associated with your particular game, but the players don't. The entire rule set and the entire system in which they're interacting with is invisible to them. All they have is the actions they complete and the feedback they get from those actions. Everything else is invisible, and more than likely your players don't care. Some of your players will be like, oh, I really want to know the precise damage count that I'm getting from this, and they're going to want to know the calculation under the hood so that they can maximize the efficiency within your game. Others won't care in any way. They'll do something, they'll get feedback, and that'll help them play your game. So the underlying mechanics are completely invisible to your player. All they have is their action and the feedback they get from the system. Everything else is a black box. Okay, so let's take a look at a couple of examples on where things can break down, things that you should be looking for in your game whenever you are playtesting. So the first thing we're going to talk about is a disconnect that can occur when we lack feedback. So your player does something and they seemingly get no feedback from that particular action. And this occurs fairly often, actually. Fairly often. An example I've given here is no feedback when shooting an enemy in a first-person shooter. You've got an enemy in front of you, you've got your reticle on the enemy, and you are pulling the trigger, and you can hear the bang, bang, bang of your gun, but the enemy is not reacting in any way. Are you affecting the enemy? Are you damaging the enemy? Is the enemy AI poor? You have no idea what's occurring. So you don't have that feedback when you're shooting at this enemy. And without that feedback, you can't make a decision whether or not your actions are doing anything at all. Do you want to continue these actions or not? Without that feedback, it's impossible to understand how the game is working. All right? I actually find this occurs a lot of times with brand new level designers as well. They set things up in an improper order. So let's take a look at an example of a locked door. You've got a player who doesn't know they're locked in somewhere. Let's say they don't know they're locked in somewhere. They're doing this dungeon crawl, and they stumble upon a key during this dungeon crawl. They find a key. The key goes into their inventory, and they can actually see the little icon for the key appear. So that is a really great loop that we've got there. The player steps on the key. It goes into the rule set. Stepping on the key goes into the rule set. And we add the key to their inventory, and we give them feedback through an icon that is delivered in the interface. Great, that part of the loop works fantastic. However, if the player has no idea what's locked, and we don't actually indicate when that key is used, and this often happens. I find this happens a lot with new level designers, that we give no indication of when the key is actually used. They have a key, and now suddenly all doors are open. Well, did that key open up every single door in the dungeon? Did that key have a specific door that it opened? If we're not given feedback to allow the player to understand that this key did this particular thing, then it was really pointless. They don't even know that they were locked in, for example. If the entire point of the player is that they are looking for a way to get out of the dungeon, there's a door that's locked, and they know it, and they find a key, then they're going to try that key out. So in proper level design, what you'll probably want to do is have the player stumble upon the door that they're trying to unlock first. They're going to try the door. When they try the door, that's the action. The rattling sound of the door handle and the door not opening is the feedback they get, and they understand that they're locked in. We could take that further and give them feedback saying the door is locked or something to that effect. All of that is going to update their mental model. Now the player understands that they are in locked into this location somehow, all right, by this particular door, not somehow, by this particular door, and that they need to find some way of opening that door. As they go through the rest of the dungeon and they come upon a key, and once again they move on to the key, that's the action. The key then, through the rule set, the key gets added to their inventory. They get the feedback of the key adding to their inventory. They maybe get a little text saying, you found the golden key, and there's a match between the golden key and the golden door, let's say. Now the players are able to update their mental model. They're able to say, okay, I found the golden key. I remember the golden door. They can head back to that door, and they can try the key on that door. Now, if they try the key on that door and the door unlocks, well, once again, we've successfully confirmed our mental model. We thought that the key was going to open the door, and the door opened when we used the key. Awesome, we've updated our mental model. If, however, we go there, we try the key, and the door doesn't open, it still remains locked, well, again, we will update our mental model and understand that this key is not for this lock. All right. So the order in which, for level design, the order in which you are giving your player information goes a long way in the proper formation of a mental model, right? Show them the locked door, allow them to find the key, and then open that door with the key. That is a successful loop. Right there is a successful loop. The opposite, I found a key, I have no idea what it's for, and all the doors in this dungeon are open. I have no idea why I need this key, is a no feedback loop. That's where your loop is breaking down. Okay? So that's one form of a broken loop. The next one we're going to take a look at is when no action is taken, but the player has feedback. And you might be thinking, well, how the heck does that occur? If the player's not aware they've taken an action, first of all, that can be the case. That the player has no idea they've actually taken an action. And something occurs, then they'll be really confused about what's happening. So again, we'll have feedback. We'll understand what's happened. Maybe within the game, I died. I don't know why I died. You know, that's actually something we hear all the time. I've been in a lot of different student playtest sessions, and sometimes we'll hear, I don't know why I died. You know, that's feedback we'll get from a student game. I don't know why I died. If the player is not given any feedback other than you've died, well, their mental model has been updated there. Yes, I understand that I've got feedback. I am dead. I've got a text here or a red screen that says I am dead. So I have updated my mental model to the fact that I am dead, but I have no idea why I died. Did an enemy shoot me? I didn't get any audio feedback. If there was nothing that was given to me to understand why I died or what's happened with my game, this lack of action that was taken and yet I'm still dead refers to this particular type of loop where the player is unaware of what they've done. If you get a player saying things like that, I don't know why this happened, it oftentimes will be because of a lack of action or a lack of feedback, right? If you have no idea what's occurred, you've done no action at all, but suddenly something occurs because of it, you're going to wonder why. Is it on a timer? What's happening here? I don't understand, right? So if you get that type of error or that type of feedback from your playtesting, you might understand now that it is a no action loop. The last kind of loop we're going to take a look at is a misinterpreted feedback loop. And again, this can occur. Now, the big problem with this one here is oftentimes the feedback is given. So the player has taken an action, they have a mental model, the action is taken, the action goes into the rule set, and the rule set produces some type of feedback. When the player sees that feedback or hears that feedback or accepts that feedback, however you want to say it, whenever the player accepts that feedback, it will update their mental model. But if they are misinterpreting the feedback you've given them, then their mental model will be updated incorrectly. They will assume that something is happening because they've done something, but it's not necessarily the case. So if you've got simultaneous actions that are occurring, let's say that every time you push a button, a door opens somewhere, but at that precise moment, because of some other loop that's occurring, some other actions performed, a sound, a bell goes off or whatever happens, then the player is going to assume, okay, when I press this button, it makes that bell work. Right? Or something like that's going to occur. It's that misinterpreting of the feedback that they're given that causes them to update their mental model incorrectly. And with that incorrect information, it makes it more difficult to play your game. If you don't understand the precise, or you think you understand the precise nature of the action you've taken, but it's not actually what's occurring from the rule set, it's just a misinterpreted feedback, then the player is going to continue to do that action and expect the same results every time. If they don't get the same results every single time, then that will again lead to confusion, right? They'll have this mental model, and they won't understand why it worked in a previous point, or they assume it worked at a previous point, and it's no longer working, right? So if your mental model is updated incorrectly, or the feedback doesn't allow us to update our mental model properly, then again, our player is missing out on information that's going to allow them to play your game. So take a look at some of the loops you have within your game. Listen as you're doing your playtest sessions. Listen to what your playtesters are telling you and look for these errors as far as loops, as far as missing information from your loops. Okay, guys? The next idea I'd like to take a look at as far as loops are concerned it's moving away from the idea that we just spoke about, moving away from an action feedback loop that we were talking about previously. Instead, I'd like to take a look at the idea of a game loop as a collection of actions that kind of drives a game forward, that allows you to progress within a game. And this type of loop I call a play loop. That's what I normally call it, a play loop, rather than a game loop. It kind of confuses the two ideas, I think, when we call everything a game loop. And depending on what paper you're reading or which academic study you're reading, it's going to refer to both of these different things as a game loop. So I personally refer to one as a play loop. The collection of actions that cause a game to progress, I call a play loop. But it's not an industry standard term, so you might want to continue to refer to it as a game loop. All right, so it's really important to identify your core game loop. We're going to talk about that idea today, the collection of actions that really define your game. We're going to talk about understanding that. And if you're able to successfully identify your core game loop, and your core game loop is enjoyable to play, then your players are going to have a good time. They'll become engaged, to use an appropriate term. They'll become engaged within your game. However, if your core game loop is not enjoyable, not engaging, then your players are going to put down your game and walk away. Okay? So let's take a look at the idea of a game loop. Now, again, we're going to take a look at what some of the things that Daniel Cook has said. Daniel Cook has said that there are several different options as far as game loops are concerned. Some consist of fast, frequent loops, and all the way up to very slow, infrequent loops. And that's what your game is made up of. All of these different collections of actions that define the gameplay within your game. And they're enveloped inside of each other, just like we took a look at Sharmi Kim's idea as far as the core mechanic and the enveloped structure of a core mechanic being enveloped within secondary mechanics, and so on and so on and so on. Your loops can be kind of enveloped within each other, right? Your loops can contain other loops that define your gameplay. So a quick example here: accept a quest, complete a quest, and level up is a dungeon crawler loop that covers a long time span. Explore, fight mobs, collect loot is an example of a generic dungeon crawler loop that covers a medium time span. And lastly, select target, attack, cause damage is an example of a dungeon crawler loop with a shortened time span. And we can see how all of these things are kind of embedded in the other. The short time span loop is embedded within the medium time span loop. And finally, the medium time span loop is what's going to make up the longer time span loop. They're not always all contained like this, but in this particular case, each of these are the lower ones, the faster ones are contained within the ones above it. We've already suggested that a game loop are multiple mechanics that chain together to form a larger repeatable pattern used throughout the game. We've already suggested that this repeatable pattern is what's going to drive gameplay. And I've already said that you can have several different lengths of these loops. Now, there's going to be one loop in particular that's going to be the most frequently used loop. That most frequently used loop is your core game loop. All right, that is the core gameplay that you are offering your players. They're going to be doing this the most. So the thing they're doing the most had better be super fun. All right, because if they're doing it over and over again and it's not fun, your players will not become engaged and they'll walk away from your game. So let's take a look at a generic RPG dungeon crawler as a quick example here. We've already talked about previously the idea of having a core mechanic within a game, and as long as that core mechanic is enjoyable, then your game is going to be enjoyable as well. And we also talked about the idea of a core mechanic being a collection of actions, or it could possibly be a collection of mechanics that are used to form the core gameplay of your game. And this is very similar in terms. The core game loop is very similar in terms. This is an example of the use of Sharmi Kim's diagram right here in identifying the core mechanic, secondary mechanics, progression mechanics, and the narrative mechanics. All of that is shown within this particular diagram. We can do exactly the same thing. We can clearly identify a game based on its core game loop as well. So in exactly the same way that we were able to create a diagram representing the mechanics of a game, we are able to create diagrams that represent the loops within a game. And once we understand what those loops are and we can identify them appropriately, we will be able to adjust those particular loops and the player's engagement based on how important those loops are within our game. So here's an example of a diagram that will show a semi-frequent loop, a start quest, complete quest, and level up. In this particular case, this is a medium length loop, as we talked about before, right? That the player is starting a quest, they complete the quest, they level up, and they start a quest again. This is a loop they'll complete throughout their game. It's obviously not the core game loop. If we start to talk about the core game loop of a generic dungeon crawler, it's going to be explore, fight enemies, and collect loot. This is going to be the core game loop of a generic dungeon crawler. So again, we can see the diagram here. And once we understand that this is the core of our game, it's going to be really important that we concentrate on the core. Fighting enemies better be super awesome, right? I think that we can even break this down further, like I did previously. We could break this down further into the little tiny loop that occurs whenever we fight, the actions that we take whenever we fight. In fact, I think that's probably the core game loop. I said how you're arguably the core game loop, and I'm arguing with myself. The fighting the enemies is probably the core game loop of a generic dungeon crawler, right? Having that minute interaction, push this button, cause damage to your enemy, get the feedback about the damage you're causing. That core loop is probably going to be that loop is probably going to be the core loop of your game, right? And making that fun is going to make your game fun. Okay, awesome. In exactly the same way that we can identify a game using Sharmi Kim's core mechanic diagram, we could be able to do so utilizing a game loop, identifying the game's core loop. So for example, start, move, kickball, score is going to identify soccer. And I think we can all agree that would be soccer. Now, you're not here to answer these questions, but spawn, drive, hit ball, score. That would be a particular game. Rocket League is what I was referring to in that particular case. Roll dice, move, property mechanic, buy, pay rent, etc. would be the core game loop of Monopoly. Okay, so we can identify games based on their core loops, or we should be able to identify games based on their core loop as well. Now, again, as I mentioned a whole bunch of times, this is an extremely important point, that in identifying your core game loop, you can identify where the engagement within your game exists, right? This, by having a strong core game loop, you're going to drive engagement. And Salen Zimmerman said, often, very often, when a game simply isn't fun to play, it is the core mechanic that is to blame. All right, everyone, that takes us to the end of this particular episode. Go through the games you're creating and understand what your core game loop is. Understand where those loops are breaking down. It's really important to do so. And once you've got that, you will make yourself a far more solid game. All right, everyone, I hope you did enjoy it. If you did, let me know down below with a thumbs up. And if you didn't, a thumbs down is perfectly fine. All right, everyone, thumbs up. Thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.